In this lesson, we are going to learn about elasticity. First, you need to understand what is rigid body. What is a rigid body? Rigid body is a solid body, like this scale, that has got a different size and shape, right? So this is a rigid body. Now, no solid body is perfectly rigid. Solids can be stretched. If you pull this, the length will change. Solids can be compressed. Solids can be bent. Right? So therefore, no solid body is perfectly rigid. When we apply an external force to a solid body, the solid body can get deformed. If we apply an unbalanced force to a solid body, the body accelerates. This is what Newton's second law tells us, Newton's law tells us. In fact, first law also tells us the same thing. Right? External unbalanced force can accelerate a body. But if we apply a balanced force, equal opposite forces like this, the solid body gets deformed. Unbalanced forces can deform a body, right? Now, what is deformation? Suppose we apply a force to a solid body, which is not free to move. So this is not free to move. And not free to rotate. Not free to rotate like this. It is not free to rotate. I hold it like this. Then the molecules that make up the body undergo a change in their relative positions. Right? So apply a force like this. The molecules are changing their positions with respect to each other. And because the molecules change their position with respect to each other, the solid can have a change in length, a change in volume, a change in shape. And that is what we call deformation. And a force that causes deformation is called deforming force. So deformation is proportional to deforming force. More deforming force, more deformation. Less deforming force, less deformation. Right? Now, deformation can be three types. Deformation can be due to change in length. Deformation can be due to change in volume. Deformation also can be due to change in shape. So these three kinds of deformations are possible. Right? And this deformation is proportional to deforming force. Now, what is this elasticity? We are trying to learn elasticity. So what is elasticity? I apply a deforming force on this scale. This scale has a tendency to come back to its original shape and size once the deforming force is withdrawn. This is what is called elasticity. The tendency of a body to turn to its original size and shape once the deforming force is withdrawn. That is elasticity. Certain bodies are perfectly elastic. They completely turn to their original size and shape after the removal of the deforming force. The best example is quartz fiber. So a perfectly elastic body will completely return to its original size and shape once the deforming force is withdrawn. Now, certain bodies will have a tendency to remain in deformed state even after the removal of deforming force. This bottle, I apply some force on this. This bottle gets deformed. Now I remove the deforming force. This has a tendency to remain in the deformed state, and that is called plasticity. The tendency of a body to remain in deformed state even after removal of the deforming force is called plasticity. The best example of a perfectly plastic body is putty. Putty that we put in walls, okay, before painting, perfectly plastic body. Putty is one example. Paraffin wax is another example. Right? These things remain in deformed position even after the removal of the deforming force. In general, bodies will neither be perfectly plastic, neither perfectly elastic. They will be lying in between. And those bodies, we call them partially elastic bodies.